So one of the modules for engineering and surveying was to make a resource for students who are learning leveling and also who are learning how to calculate an area by doing an area traverse. So when I stepped into this project, two parts of the project were clustered into one, just because the same equipment is used for both of these exercises. I looked at the course material and I decided to split it into two parts. So I'd been a TAFE teacher before, and we use zero knowledge. We assume zero knowledge from students. So I decided to build something from scratch, which would help the students. They could use it as a resource before they came in for the intensive exercises. They could use it as a resource for revision. So taking leveling and also taking the module of area traverse, I decided to split it into two parts. I made contact with a friend in engineering and surveying. He introduced me to Luke. So Mohan Tada was my contact person who introduced me to Luke Saban, who then got me in touch with Nabraj Subedi, a PhD student who took me through the entire process. And Luke suggested that I go and learn myself what it is so I can make a better resource. So they've been very, very supportive in building the resource, except they haven't been able to give a lot more time. So we are still in the process of building it. And one part is almost done. So what we have achieved so far is leveling. And I will talk about the area traverse as well, which I have done. So in leveling, what we have here, if you see, when I went out with Nabraj Subedi, in fact, even before I went out with him, I decided to familiarize myself with the terms like a reduced level, back site, a foresight, and intermediate site. So that helped me in completing the practical exercises. So I put myself in the shoes of a student, and I did these practical exercises along with Nabraj Subedi. So when I went through the process, I realized, oh, these are the terms that I really, really need to know. So the first page of my resource is actually a glossary of terms, just to make a student understand what are the terms that they need to be very, very familiar with. And then I illustrated them in a diagram to explain what a backside is, what a foresight is. So generally you put a level in a position and you take readings. That's a backside and that's the foresight. And anything in between is an intermediate site. And students start understanding that the foresight is actually, when you move the level, that same foresight becomes a backside for the next reading. So I put the leveling terms. I took photographs when I went out with Nabraj Subedi. I split it into small chunks so that it would be easy to digest. To familiarize the students with equipment, I took photographs. This is a YouTube video, and I'm encouraging the teachers to record their own video here because we have a production team. These are some still photographs I took when I did the exercise. So we haven't got the photographs taken professionally yet, but I wanted to put the whole storyboard together to introduce what are the different pieces of equipment we use, how a reading is taken when you look through a level. Now in this particular exercise, what we have here is a small demonstration and steps. And these are exactly the steps that I did to do a closed level run. There's a small video which explains the level run. It's still in animated form. Ideally, it will be a video. The storyboard for these I'm going to make. Like this itself right now serves as a storyboard as to where you place your staff, what reading you take. And then that storyboard is explained as a still diagram. And how do we record the readings? This is where the serious stuff begins. So it's not only just putting a level and taking a reading. How do you record the readings and what do you do with the readings? How do you check whether your readings are right? So there's an example of a table as to where each reading is placed in the table. Further on, there's an exercise where students can go and practice. Now, the level run requires focusing, so I've simulated focus here. So they have to try and focus and take a reading, very sharp reading. So that's the sharpest I could get. So we have 2.5 meters, 2.51, 52, 53, 54, 5, 2.545 meters would be this reading, and that's BS1, so you enter it here, BS1. Going further, that would be the FS1, a foresight from position 1, and so on and so forth. You take the readings and then you calculate the total of the backsides, total of the foresights, and you check whether the difference is equal to the rise or fall. And if there's an error, you record an error. So this was one of the exercises, very basic exercise for a student who's never done anything in surveying and engineering before. Coming to the two-peg test. There was a request to include a two-peg test. Now this test is used to find out if there's an error in the instrument. It's quite possible that a level that you use has an error. And there is a method used by surveyors to find that error and to compensate for that error. So the two-peg test, I got some stuff, I studied it on the internet, got some resources, and it wasn't terribly difficult. So I put it in this resource, what the two-peg test is, how to discover the error, and how to apply the correction. There are some terms that are different to the study desk that we use here at USU, and those terms have to be fixed. There are some other exercises as well, just to drive a few of the points. For example, using the spirit level. So when you adjust the screws, of course, you have to adjust the tripod perfectly, but the fine adjustment can be done with screws. And this simulates that adjustment where you try to get the bubble to be in the center. And there's another exercise we have simulated here just to drive a point that the level has to be placed between two markers. So what I have here is a small simulation. You can place two markers and there's a level, and you get the distance between the two markers. And you try to sort of get them exact. So we've got some simulations here just to drive home some points so the students can remember certain things. The second part of this resource was to calculate an area given 4 points. Once again, I went out with Nabrat Subedi and I did the exercise myself. And while we were doing the exercise, I took some photographs to understand the process. Let me just change this to thumbnails. Okay, so that's a total station, and that's the equipment that we had used. These are pegs and hammers. That's a benchmark. That's a point whose height is already known, whose elevation is known. That's a prism. So I recorded all the things that we need to do. And that's pointed exactly in the direction of the prism. And that's the total station being used. Now this total station has to be used to point from one point to another, right? And readings are taken in a particular way. There's a particular process for it. You have to take a reading facing left, and then you have to take a reading facing right. So there are 3 parts to this exercise. One part is knowing the equipment and understanding how to use it, to take it into the field and to use that equipment. You start with a benchmark, and I'll show you here. If you see here, point K, which is B17, benchmark 117, it's a known point whose height is known. Its location is known, coordinates are known, and the other point is B51. Now these other points, B, C, D, are totally unknown points. We start calculating their easting and northing, as in how much to the east of this point does it lie, or how much to the north of this point does it lie. And there's a surveying process to it. The readings are recorded in a sheet. So you place your prisms and your total station in a particular way, in a particular sequence, and you take your readings. And you can see here, so starting from point A, pointing towards point K, and facing left, and then there's a facing right, same, point A to point K, but facing right, which means you turn the total station 180 degrees and you take the reading again. Then from A to B, you record the distances, you record the horizontal angles, and you start recording all of the readings that the total station gives you. So taking these readings is one thing. Then to minimize the error, we start taking the average of these readings. We then go and start calculating the coordinates of the other point, the easting and the northing, and we apply some trigonometry and the area of a trapezium to actually get to this area. So there are three parts to this in which this resource can be built. One is going out in the field and recording the process of taking the readings. Second is understanding how those readings are used in these 4 steps. And the third part is revisiting the trigonometry and the math that sits behind this. So there are 3 distinct parts to this process, which if put into a single resource as one a video, one as a screencast of, let's say, this Excel sheet, which is explained by a teacher, and the third is revisiting the math, then you have a complete resource of calculating area. So this is a resource that I haven't built yet, but I've gone through the exercise, and this is the material that I have on it. So I've done quite a few projects in this area. This was Chinese character animations. So Chinese characters are written a particular way. They are animated in a particular way. It's important the way the strokes are drawn. So I made about 47 animations for another project. In fact, in this animation, a few of the strokes that I ended up doing were erroneous, which I fixed later. I think one of the ones that I enjoyed most was this protein model. So first I tried to draw it by myself. I used 3D Studio Max, and the teacher said, hey, this looks nothing like the protein. So this one on the left is totally a visual approximation, and it had to be perfect like the one on the right. So actually I used a software from the University of California, San Francisco, to generate a model, import it, and to render it. And we ended up with this nice 3D interactive model. In fact, I even took it into Unity Game Engine with the hope of looking at it through those VR goggles. This would really look nice. If you could spin it in the VR world, you could actually walk in. And even here, you can pretty much zoom into it. You can see I can zoom in and out of this, and I can turn it around. Another really, really useful one from a university's point of view was the campus map. So the campus map started initially as a project to give autistic students an idea of what different parts of the campus look like, so they can plan how to get to G block without walking into crowds. So giving them an idea of what the campus looks like. But it expanded into providing information, all sorts of accessibility information. So it stretched a bit further, which was nice because now in the current version, students can choose to see the map. They can choose to see where the disabled parking spots are, which blocks have disability toilets. Now, although there are some blocks which don't have disability toilets, like G block, and it doesn't even have a lift. If I put lifts here, you'll see G block doesn't have a lift, nor has disability toilets. But the information on G block, if I go into G block, it actually shows me what's the nearest lift and how I can access the higher levels of G block from adjoining blocks, and how I can access the nearest disability toilet. So it actually says T block and W block are the nearest disability toilets. So this was it was a very gratifying project, because I know it will be used and it will be helpful to students. We have a similar one with a map. In fact, all the experiments we did in the previous project, they came in handy because we could transfer that knowledge and all of the skills that we had learned in creating interactive maps to this particular project, which was a cultural audit of different spots in Toowoomba City. And it has the audio recorded by the production team. In fact, both of these projects, this project and the previous one, were complete MDD projects. It had photographers involved, it had people from the production team, audio, video happening, you had graphic designers involved. In fact, the whole team was auditing the campus to find out if the information was correct or not. A complete MDD project. So they were really, really nice, comprehensive projects by the team. There are some games which we make. So this was one of the games which we made for student services. And fortunately it works. So the idea of this game was to inspire students to overcome the mistakes. So you basically type a mistake that you might have made. I forgot to write an assignment. What do you learn? Learn to set reminder dates. And the whole idea was to give students a chance to whack their fails. Not sure how effective it will be, but this was it. And you scrunch your mistake and you whack your mistake and try and tell yourself, yep, I've learned from it, I'm going to learn from it. Well, I haven't learned so far, have I? Let me try one more. Okay, I'm bad at learning. Another useful game that I felt was done for fleet management course. I felt this was really, really nice because there was a lot of information that has been fed to students in the form of a game. What happens in this game is students can choose a destination, a load that they want to transfer to that destination. For example, you can see Grafton, Coffs Harbour, Sydney, and Port Macquarie. They're different loads, they're different distances. And then you choose an appropriate vehicle based on the load. For example, for a tiny load, if you choose a truck, you get a warning. Consider using a smaller vehicle to save costs. Or if you take a larger load, then you get a warning saying reconsider trailer combination. So if I need to add a trailer because my load is in excess, and I get another warning, you cannot add a small trailer. Finally, this is a good combination, a truck and a big trailer. You start learning so much. And not just that Coffs Harbour is 547 kilometers from Toowoomba, which is also good information to know, but things like a truck generally can carry 8 tons. That's the average tank size. The mileage you get is 20 liters per 100. And if you put a big trailer, your speed limit will actually reduce to 80. So there's a lot of knowledge built into these tiny bits and pieces of information. Finally, you can go and choose a driver. Now, because I have selected a trailer, there are certain licenses required. And this fellow Bert here, although he's cheap at $30, he doesn't have the required license. Neither does Tommy's license. Pammy can hire. So Tommy's license doesn't, Bert doesn't, and Cindy is very expensive. Let me go for Pammy. What this game allows a student to do, and I can do maintenance checks. If I don't run checks, and I forgot to click, that means there's a chance of a breakdown. What this game allows student to do is that, yes, I'm above the speed limit. It allows a student to simulate a journey and calculate a price per ton per kilometer. Now you can't see my entire screen here, but you can see there's a dashboard at the bottom in which I can see my speed. I could occasionally get a speeding fine as well. I'm just going to zoom out so I can see the total cost on top as well. So there's a total cost associated with my journey. You can see all the details. If I run out of fuel or if I fuel up, the fuel cost gets added. After every hour, the driver's wages ticks over, and you can see the next hour the driver's wages have got added, and so on. if a student undertakes 10 journeys on this game, they can easily find the price per ton per kilometer without having taken a truck out of the base and driven it to any place. So it's a great simulation for students. On similar lines, we are now doing a second project which tries to teach the students tasking. So you start from a base, you go on to another depot, drop some load, pick up some load, and you pick up some load, and you keep on going. You take your breaks, 2 hourly breaks. You try and take would you like to fuel up? Yes, if I add fuel, it'll add the cost. You claim your allowances and overtime during the night, and so on and so forth. So that's the second part, which is being done as a 3D animation in addition to this game, as an additional resource to make it easier for students to understand the topic. Apart from that, I mean, there are just a few games here and there that we have done for an experiment. For the production team, I think this one was a nice one for the production team to try and give an idea to users sitting in front of a green screen like I am to remember what to wear. And I was actually thinking this morning what to wear. So you have these outfits and you have to guess whether it will work or it won't work. So yeah, that was another project.